In our previous video, we studied different parts of the human eye and their functions. In this video, we're going to roughly see how light propagates inside the eye and how we're able to see the objects around us. And for that, we will consider a simplified two-dimensional image of our eye. So how does light travel inside? Suppose we're looking at an object which is some distance away. Not too far away though. The light from that object enters our eye and falls on the cornea first. What is cornea? It is this curved and transparent outer layer guarding the entrance of the eye. First, the light is refracted by the cornea. This refracted light then travels to the transparent fluid present in between, which is also called the aqueous humor. From this fluid, light then enters the pupil and falls on the lens inside. This eye lens is a biconvex lens and it refracts the light such that all the light coming from a point on an object is focused on the retina. This is where the image is formed. Clearly, the image that you see is a real and inverted image. But wait, we don't really see the world around us being upside down, do we? We see everything as is because this image again gets upright in the brain. We know that these light signals travel through the optic nerve as impulses and travel to this part of the brain. It's known as the occipital lobe. However, before this light falls on the retina, it first travels in the space between the retina and the lens. This space is filled up with another transparent fluid called the vitreous humor. Yes, there's aqueous humor between the cornea and the lens, and there's vitreous humor between the lens and the retina. So this is how the light travels inside the eye. There are multiple refractions occurring inside. In fact, much of the refraction occurs before the light reaches the lens. Let me get a bit technical here. Look at the eye closely. What are the different mediums through which light travels before it reaches the retina? There's air, then there's cornea, then we have the aqueous humor, then the lens, and finally through the vitreous humor. And here are the approximate refractive indices of the media. Now, if you notice, the refractive indices of air and the cornea are largely different, whereas the others are not significantly different. Hence, most of the refraction that happens are the air-cornea interface. Refraction does occur at other interfaces too, but not as much as this interface. The lens also refracts the light. However, its main function is to make sure all the light from a point is focused on the retina only. Yes, it just fine-tunes all the light so that the image is formed on the retina and not anywhere else. But how does the lens do that? We have studied the properties of images formed by biconvex lens in the past. We know that for different positions of an object, the image is formed at different locations. But this does not happen inside the normal eye. The lens inside the eye always forms the image on the retina only, not in front or behind the retina. Why is that? This is because the size and the shape of this lens are not fixed. This is a flexible lens composed of fibrous jelly-like material. Therefore, the lens can temporarily change its shape up to a certain extent. But how? This movement of the lens is controlled by muscles called the ciliary muscles. One of the most widely accepted theories says that when the ciliary muscles are in a relaxed position, the lens is thinner and hence it has a larger focal length. And when these muscles contract, thickness increases and hence the focal length decreases. So when the object is nearer, the lens increases its thickness to form its image on the retina. For a faraway object, it becomes thin and the image is again formed on the retina. So that's the whole point. By adjusting its shape, the lens makes sure that the image is always formed on the retina only, not in front or behind the retina. The ability of the lens of the eye to adjust its focal length accordingly is called accommodation. Now obviously, there is some limit to which the lens can increase or decrease its focal length. One of the cases is when the object is too close to the normal eye. If you take an object very close to your eye, the image appears to be distorted. You will not be able to see the object clearly. This is because the image is not formed on the retina. In that case, we have to strain our eyes in order to view the object with clarity. When we strain our eyes, what we are actually doing is trying to reduce the focal length of the lens. We can try that, but we will still not be able to see the object clearly. So how should we fix that problem? The solution is simple. The object should be kept at such a distance from the eye that the image is formed on the retina only. This distance is called the minimum distance of the object from the eye, and for the normal eye, its value is around 25 centimeters. Okay, so what did we learn from this video? We learned how the light propagates inside the eye. Most of the light is refracted at the air-cornea interface and then falls on the lens after traveling through aqueous humor. The lens then focuses all the light through the vitreous humor on the retina by adjusting its focal length. In the next video, we will study a few eye defects.